So in this problem, we're going to try to figure out what is the behavior of this latch here. And whenever solving any latch problem, what I recommend you do is find a set of intermediate signals. So we're going to call this guy M and this guy N. N. And what we're going to do is treat this, so we're going to look at this cross-coupled NOR separately from the rest of this. Once we figure out what behavior is here, we'll figure out what behavior happens over on with these D and E gates. So the first thing we want to try to figure out what is inside of this box here. So what we're going to do is solve for Q and P in terms of M and N. And so what we're going to do is say is Q plus is equal to, so here we've got M and P NANDed together. And then we've got P is equal to Q and N NANDed together. So what we're going to do is do a variable substitution up here, and now we've got M, Q, N. This is NANDed. And so this should give us, should give us our overall behavior. We could also do a back substitution here. Substitute Q in for P, so P plus is going to be equal to M, P NANDed with N bar. Okay, so now we know what the value of each of these Q and P are with respect to their own inputs. So what we can figure out here is that if we put M and N in for Q plus and P plus, we put 0, 0, 0, 1, 1, 0, 1, 1. When M and N are both 0, so this will be 0 ANDed with anything is equal to 0, which becomes a 1. So this whole part becomes a 1. And then 1 and 0 becomes a 0. And then 0 and NOTted becomes a 1. So this becomes a 1. And then down here, we've got N is 0. So N is 0. 0 ANDed with anything is 0. So that all of this is 0. And then we NOT that, so that becomes a 1. Now, the next behavior is M is 0, so as we just discovered before, that's going to make Q plus 1, because 0 and anything is 0, and then NOTted becomes 1. And then we've got N is equal to 1, so now we need to figure out what's going on inside of here. And so we'll see that we've got M is 0, ANDed with P, 0 ANDed with P is 0, so this whole thing is 0. And then that becomes a 1 because we NAND it, so 1 and 1 is 1, not that, it becomes a 0. Now the next thing, so basically it's going to be, you can kind of see that these are similar to each other, so we're going to see that this is 0, this is 1. And we can do that really quickly if you want. N is 0, that's going to make this whole expression 0, but we complement it, so it becomes a 1. And then this is a 0, making this guy a 0, which means we complement it, so it becomes a 1. Once it's complemented, 1 and 1 is 1. Complement that, becomes a 0. Okay, and then we've got two 1s. And so here we've got, this becomes Q bar. 1 and Q becomes Q bar. And then 1 and Q bar is Q bar. Then we complement Q bar, and that becomes Q. And then we've got here we've got M, 1 and P becomes P, but then we complement it, so it becomes P bar. And then P bar and 1 is P bar, but then we complement the whole thing, so we get P. So we've got our, we can see this is basically an SR latch with everything being complemented. Okay. So we've got that behavior now. So now the question becomes, what is the behavior based on D and E? So M is equal to D, E NANDed, and N is equal to M, E NAND, which, if we do a variable substitution, is D, E, NAND, NAND. All right. And so what we'll try to do now, so we'll do a second table. Once we have D and E, we'll choose all of their values. I'm going to simplify this guy using De Morgan's law. So this becomes DE or E bar. I think it'll make my life a little bit easier. So then we just need to solve for M and N. So M is just the NAND of D and E, so it's going to be this. That's the NAND. And then N is going to be 1 whenever E is 0. So 1, 1. And then whenever D and E are both 1, it'll also be 1, and then it'll be 0 here. Okay, so what we can check out now is basically if E is 0, we're going to do a hold operation. So let's write this out one more time. So we've got 0, 1, 1, 0, 1, 1. And what's going to happen is Q plus P plus. I can solve for this. I can see that when D and E are 0, I've got the 1, 1 for my inputs. And I can see that QP comes out. And then when these guys are 0, 1, M and N are 1, 0, which gets me the 0, 1 row. And now I've got D and E are 1, 0, which tells me it's a hold. So it's QP. And then 1, 1. When I insert that, I get 0, 1, which is this row here, and I get 1, 0. And that's the behavior of my gate, my latch, which happens just to be a gated D latch.